All right, so welcome back. So yesterday we talked about graphing quadratics in standard form with an a value of 1 or -1. So we're just going to quickly review that. So hopefully you guys remember here. You see on your screen you got a quadratic here. This is the parent graph because the vertex is at 0, 0, and it has that growth pattern over 1 up 1, over 2 up 4, over 3 up 9. So that way there's our vertex over 1 up 1. We can flip that over 2 up 4. We can flip that over. That's that pattern we need to remember. So let's see if this will let me do this or not. Probably not. Nope. All right. So what we're going to do today is we're just going to try to graph those real quick. So I want to make sure we understand what's going on here. So move this out another way somewhere. And why isn't that working? There we go. All right. So let's say we want to graph at number 1. So remember, the inside lies. That's what moves it left and right. So that means we need to go over +2 horizontally. Then we got to go down 3 vertically. So we'd have a vertex at 2, -3. Then we could plot our points. So number 2, we got to do the same thing. So +3 on the inside means we got to go back 3. Oops. Let's go back 3. And then the +1 on the outside means we need to go up 1. All right. So now the last one there, it's got a negative, so that means it needs to open downward. So we're going to flip our graph over. Then we're going to try to graph this. So -1 on the inside means a +1 right here. And then we need to go up 3, right? So that's what our graph would look like. So really, we're just sliding a graph around. It might be opening up or down, but we'll talk about stretch factors tomorrow a little bit. So let's move on. Today, we're going to be talking about the absolute value graph. So an absolute value is very, very similar to the quadratic. Oops. So the domain's the same. The way you handle range is the same, but the growth pattern's different. So hopefully you remember that absolute value is the distance from 0. So your parent graph looks like this. So this would be y equals the absolute value of x. So now we want to graph this one. Let me actually use the straight lines. So it looks like a V. So quadratics look like a U. They have curves. Absolute value is like two linear equations that meet at the vertex. All right, so like I said, very similar. And again, we're going to be focusing on A being 1 or -1. So we will practice some stretch factor stuff, but we're not going to go too crazy into it. So it's either going to open up or down following this pattern of up 1 over 1. All right, so the vertex is found the same way. The inside is what moves the vertex left or right, and it lies. And the outside, the k value, is what moves it up and down. So let's take a look at this problem right here. So what do we need to do here? Well, first thing is we need to figure out what is our vertex. So our vertex is going to be at the opposite of what's on the inside and what's on the outside. So we got +3, -4. So I'm going to go right 3, down 4, put a dot. And I'm just going to go up 1 over 1, up 1 over 1, up 1 over 1, running off the graph there. But now, again, to try and make this look a little neater, I'm going to just use my arrows. Now we get a nice neat graph there. So now we need to make sure we understand how to state the domain and the range. So get our domain is going to be all real numbers because this thing's going to go to the left forever and to the right forever. Now the range is just like the quadratics we did. Since this one's opening up, that means it's going to be y is greater than or equal to our k value of -4, because that's the low point there. All right, so not too bad, right? All right, so the next example, we've got x plus 1, the absolute value of x plus 1 plus 4. So that means we need to go back 1 because the inside lies and up 4. Oh, we got a negative sign on there too. So that means we need to go down 1 over 1. And we just keep doing that pattern since it's negative. And again, let's try to make this look a little neater than the previous videos. All right, so what do you think the domain is? Exactly right, all real numbers. Now the range, again, on this one's a little different because it's opening down. So we have to say has a high point, so y needs to be less than or equal to the high value, which is 4. All right, so not so bad. So how about this? What if I gave you one and said, write the equation of it? How would we approach that? So let's take a look at it. We know we got y equals, I'm going to write our standard form here. So I'll plug everything in. Well, what do you think the a value is? We can see it's going down 1 over 1, down 1 over 1. So that tells us that it's a negative 1. Now we got to find the x value of our vertex. Well, that's back at negative 1. So we're going to put a plus 1 there because the inside lies. And then we go up 4 to get to our high point in the vertex. So it'll be plus 4. And we are done. It's that easy. All right, so how about this one? I'm not going to write it down again, but hopefully you see that the a value is 1 here. So we're just going to have absolute value of x something. So if we go, looks like we're going right 2. So that means you have to put a minus 2 there, right? Because the inside lies. And then down 3. Outside tells the truth. And that would be our answer. So hopefully you guys are feeling like this is pretty straightforward. Have a great